In Unit 4, we looked at geometry. Our very first learning target was constructing 3D models given the different views. So if you take a look at the first problem, we'll just jump right in. We're given a top view, a front view, and a right side view. What I like to do is I like to go one at a time and see which of my figures that are my answer choices, so which of these match up with that top view. So in my top view, I have 4 in the first column, so I'm going to look at the top views of all of these answer choices and make sure that I have 4 in the first column. So that one has 4, that's good. This one only has 3, so I know right away that that's not the right answer. This one has 4, and this one has 4. So then I'll look at the second row, which has 1 block that's lined up with the top of this first row. So this is 1 block lined up with the top of this row. This one, these two are not lined up, so this one in the middle is wrong. And then this one, you have 4 and you have 1 that's lined up with the first one that's right here. So far, those two answer choices are possible. And then I'll look at the next row. So in the next one, my front, I have 4 by 4 in the shape of a square. So I have 4 by 4. That one's good. And this one is also 4 by 4. So it could still be either of those choices. And then I will look at my right side. So on my right side, that's looking at it from this way, I have 4 blocks, and then I have 3 blocks. So if I look, I have 4 blocks in my first one, and 3 blocks in the second row. And then in my last answer choice, I have 4 blocks in the first row, but only 2 in the second row. So that's not the right answer, which leaves me as the first one being the correct choice. For my second question, I'm doing basically the same thing, but I'm only looking at the front view. In my front view, I want 3 and then 2. So I have 3 and then 2. So I know right away that that one's right. But we'll go ahead and look at the others anyway. So I have 3 and 3, so that's not right. I have 3 and 3 again, so that's not right. And then I have 2 and 3. So it's similar, but it's flipped. So that one's not right either. So that's my first learning target. My second learning target is almost the same, but now I'm matching the 2D views with the 3D models instead of vice versa. So the first question wants to know which could be a two-dimensional view of the block of cubes. And it doesn't say if it's the top, the side, the front, so we're just going to see if any of the views match up. On this first one, we have a 4 by 4 square, and while this is 4 by 4, it's not filled in right here as well, so it doesn't work. So we'll go ahead and we'll mark off the first answer choice. On our second one, we have 2 in a row, like that, and then we have 1 long row, so like that. But these 2 aren't shown in our view. That would be if that was there like that, which it's not, so that answer choice is incorrect. And we'll cross it out. We'll do the same thing with our third one. We have 2 by 2, so 2 by 2. We have 1 long row on the outside, and then we just have 1 little square here, which would be this face, and this one is not accounted for, so we know that that is not the right answer choice. We'll go ahead and cross it out. Which leaves us with the fourth answer choice, where we have 2 rows by 2 rows. And that would be the correct choice. And then we'll look at the last one in this learning target, identifying which models are represented by this bottom view. So the bottom view is basically the same as the top. So we'll have 4 on the outside row. There's 4 in that one. There's 4 in that one. 4, 4, and then this one, this last one only has 3, so we can cross it out. And then we have 3. So we have 3 here, 3 here, 3 here, and 3 here. So we can't cross any out yet. And then we have one little extra one. So this first one doesn't have one little extra one, so we'll cross it out. The second one does, so that's one answer choice. So does the third. And the fourth has it, but it has this extra piece right here. So we can cross that one out. So that leaves us with 2 answer choices. Notice that it said to select each or identify each, which means that there's going to be more than one answer choice. Learning target 3 is when we started looking at the different angle relationships. If you don't remember what these are, remember that the word adjacent means next to. Vertical was across from each other. Complementary meant that it added up to 90 degrees, and supplementary meant it added up to 180 degrees. So if we look at our first one, these angles right here are across from each other, and therefore they are vertical. On our second one, angle 7 and angle 8 are on a straight line, so they add up to 180 degrees, which means that they're supplementary. The next one, 55 plus 35, is going to add up to 90 degrees, which means you have complementary angles. In our fourth problem, these two angles, angle 5 and angle 6, they don't add up into anything specifically that we know, but they are next to each other, so we call them adjacent. On our next problem, 40 degrees and 140 degrees add up to 180 degrees, and therefore it is supplementary. And then in our last problem, and angles 9 and 10 are next to each other, so they are adjacent. In learning target 4, we take this information and we use it to solve for missing angles. So our first problem, we're solving for x, and we're finding the measures of the angles. So if we take a look, and I'll zoom in so it's a little easier to see, these two angles add up to 90 degrees. So I need to write an equation in order to solve for x. So what I'll do is I'll write 3x minus 15 plus 2x plus 10 is equal to 90. And then I have to solve. So my first step will be to combine my like terms, my 3x and my 2x, which will be 5x. And then my negative 15 and my positive 10. When I combine those, I get negative 5 is equal to 90. From there, I'll add 5 to both sides. And 5x is equal to 95. And then I'll do 95 divided by 5, which is equal to 19. So x is equal to 19. So I've solved for x, but I now need to find the measures of the angles. So what I do is I take this x equals 19 and I plug it in to the original equations. So instead of putting x, I'll put 19 in parentheses. So 3 times 19 minus 15, and 2 times 19 plus 10. And I can just go over to Desmos and plug it in just like that. So 3 times 19 minus 15 is going to be 42. So this angle is 42 degrees. And then 2 times 19 plus 10 is equal to 48 degrees. And if I want to check my work, I can take those two numbers, the 42 and the 48, and they should add up to 90, and if they do, you know that you did it right. And then we'll move on to the next question. And our next question, the angles that we're given are across from each other, so they are vertical. And remember, whenever you have vertical angles, they're equal to each other. So what we do is we take those two angles, the 83 degrees, and we set them equal. So it's equal to the 4x plus 3. And then we solve it. To solve, our first step is to subtract by 3 on both sides. And you have 80 is equal to 4x, and then you divide both sides by 4, and x is equal to 20. Now, because these are vertical angles, even before we solve and we plug in our x value, we should know that this is going to equal 83. If it doesn't, you know that you did something wrong. But we'll go ahead and check our work in Desmos. So we'll have 4 times 20 plus 3 is equal to 83. We are correct, and we can move on to the next problem. Our next problem is the same format. We have two angles that are vertical. They're across from each other. So this is going to end up equaling 53 degrees. So all we really need to do is solve for x. In order to do that, we'll subtract 3 on both sides. 50 is equal to 5x, and then we'll divide both sides by 5, where x is equal to 10. And we'll check our work just by plugging it in. So 5 times 10 plus 3 is equal to 53. We know that we did it correctly. And then our next problem, we now aren't vertical angles. Instead, what we're looking at is a straight line. So anytime you have a straight line, it adds up to 180 degrees. So what we're going to do is we're going to take those two expressions and we're going to set them equal to 180 degrees. So we add them, 15q plus 18 plus 3q. So this plus this is equal to 180. And then we solve. To solve, we're going to combine our like terms. 15 plus 3 is 18. Q plus 18. We subtract 18 from both sides. Which should be 162. And then we divide both sides by 18 to get our final answer. So 162 divided by 18 is 9. Now that we know what Q is equal to, we can solve for the measures of the angles. So we're going to take what Q is equal to and plug it in to both of these things. And then we solve. 3 times 9 is 27, so this angle is 27 degrees. And then for the other angle, 15 times 9 plus 18 is going to be 153 degrees. To check your work, you can add the two of those together, and they should add up to 180, which they do, so we know we did it correctly. And then our second to last problem is another problem where we're on a straight line. So once again, it's going to add up to 180 degrees. So 2x minus 5 plus 133 adds up to 180. Our first step will be to combine our like terms, so our negative 5 and positive 133, which should be 128. And then we subtract 128 on both sides. Cancels out on the right, and you're left with 2x. And on the left, we're left with 52. And then lastly, we divide both sides by 2, and x is equal to 26. And then we plug it in. So we plug in our x value. Then we go over to Desmos and we do 2 times 26 minus 5 is 47 degrees. So that and 133 should add up, oops, I put 27 instead of 47, should add up to 180, which it does, so we know that we're correct. And then our last problem is a right angle, which means that these two numbers are going to add up to 90. So we'll do 4x plus 5 plus 2x minus 5 is equal to 90. And then we'll solve for x. So we combine our like terms. 4x plus 2x is 6x. And then 5 minus 5 is just 0, so we won't write anything, is equal to 90. And then we'll divide both sides by 6, and x is equal to 15. And we take what x is equal to and we plug it in. So 4 times 15 plus 5, and then 2 times 15 minus 5. If we go over to Desmos and we plug that in, we'll find the measure of our angles to be 65 degrees and 25 degrees. And when we add those together, we get 90, so we know our answer is correct. So that takes care of our second learning target, our fourth learning target. It's a big difference there. And we'll move on to our last couple of learning targets. These are dealing with transformations, and we're just drawing and identifying the new coordinates of a figure after we translate. So if you don't remember what a translation is, it's when you slide your figure. So it'll still be oriented, it'll face the same way, it's just moved. So we're going to take each individual point and move them based on the rules. So in our first problem, we're moving 3 to the right and 2 down. So if this is our point, we're going to go 3 to the right, so 1, 2, 3, and then 2 down. And that will be our new point at coordinates 2, 2. And then we'll move on to our other points. So this one at the top left, we're going to go 3 to the right and 2 down. That's the new coordinate at -2, 3. And then for our last one, we'll go 3 to the right and 2 down. And our new coordinate is -2, 0. And when we connect them, we see that we're still oriented in the same way. And our next one, we're moving 3 to the left and 5 up. So we're going to go 1, 2, 3, and 5 up. 3, 4, 5. And that's at the point 0, 4. Our next point, we're going to go 3 left and 5 up. And we end up at the point 2, 3. Our next one, 3 to the left, 5 up. And we're at the point 2, 0. And then lastly, this point right here, the bottom left of the shape, we're going to go 3 left and 5 up. And we're now at the origin 0, 0. And then we have a new shape that looks exactly the same as the original. It's just moved upwards. And our next figure, it doesn't give us a coordinate plane in order to do the translation, but it's the same steps really. When we have 2 units up, that means we're adding 2, and 5 units to the left means we're subtracting 5. So remember, in your coordinates, it's x, y, where x is going side to side and y is going up and down. So we're going to go 2 units up, that's up and down. So our second coordinate, we're just going to add 2. So 5 units to the left is side to side. That's a change in our x coordinate, and we're just going to subtract 5. So using that rule, we can find our new coordinates. 2 minus 5 is -3, and 3 plus 2 is 5. So that's our new A. Our new B, -3 minus 5 is -8, and -7 plus 2 is -5. And then our new C coordinate, 0 minus 5 is -5, and 4 plus 2 is 6. So I use these rules 2 units up and 5 units to the left to figure out what I'm doing with my coordinates. So I'm subtracting 5 from the x coordinate and adding 2 to the y coordinate. My next learning target asks me to reflect. So remember, a reflection is like when you're looking in the mirror and you flip. So if we're flipping across the x-axis, that's this horizontal one right here, what we need to do is we just take our points and we count how many away they are from the x-axis and do that in the opposite direction. So if we start at this point right here, at the bottom right, it's 1 away from the x-axis, so we'll go 1 in the opposite direction. And we're going to do that for each of our points. If we look at the one to the left of it, if we're 1 away, we go 1 away in the opposite direction. Our next point is 3 away, so we go 3 in the opposite direction. Our next point is also 3 away, so we go 3 in the opposite direction. Our next point is 5 away, and so is our last. So all we've done is flip it over that axis. What you'll notice, if you look carefully, is that all of these coordinates, if we look, this one is 5, 5. The new one, the x-coordinate is going to be the same, but the y-coordinate is the opposite. So this point is 5, 1. The flipped one is 5, -1. And that'll be the case for all of them. Our next one, we are going to reflect across the y-axis, so that's up and down. So we count how far away we are from the y-axis. So this one is 1 away, so we'll go 1 in the opposite direction. This point is 2 away, so we'll go 2 in the opposite direction. And then our last point is 3 away, so we'll go 3 in the opposite direction. And then we're left with a shape that's exactly the same. And whereas in the previous example, our y value flipped, in this one our x value will flip. So this is at point 3, 0. The new one is at -3, 0. This point is at 2, -4. On the left-hand side, we're at -2, -4. So if we're given points like this, where we go over the x-axis, our y value is going to flip. So all we have to do is flip the sign on our y values. So that'll be -3, -6. This will be 9, -4. And then we'll still be at -1, 0, because -0 and 0 are the same thing. But no one says -0. And then our last thing that we do is our second to last thing is our dilation. So dilation is when you shrink or stretch and in order to do this we need to know the coordinates for all of our points. So if we look at point M, that's at 1, 3. Point N is at 3, 2. Point O is at 2, -2. And point P is at -1, 0. So when we dilate with a scale factor of 3, we just multiply all of our coordinates by 3. So I'm going to write them off to the side. And I'm just multiplying everything by 3. So point M, 1 times 3 is 3. and 3 times 3 is 9. For point N, 3 times 3 is 9, and 2 times 3 is 6. For point O, 2 times 3 is 6, negative 2 times 3 is negative 6. And for point P, negative 1 times 3 is negative 3, and 0 times 3 is still 0. So now I know all my new coordinates, so I can plot them. So point M is going to be at 3, 9, which I believe is right there. Yes. Point N will be at 9, 6, so I'll go over 9 to here and up 6. That will be my new point N. Point O is going to be at 6, negative 6. And my new point P will be at negative 3, 0. So what I've done is stretch my figure. If I dilate with a scale factor that's a fraction, it's going to get smaller. So if I look at x, y, and z, and I plot the original coordinates, it's negative 4, 2 for x. For y, I am at 6, 0. And for z, I'm at negative 2, negative 4. So I'm going to multiply all of these coordinates by 1/2. So a negative 4 times 1/2 is going to be negative 2, and 2 times 1/2 is 1. 6 times 1/2 is 3, 0 times 1/2 is 0. Negative 2 times 1/2 is negative 1, and negative 4 times 1/2 is negative 2. So I'm going to plot all of those points on my coordinate plane. So negative 2, 1 is right here. That's my new x. My new y is at 3, 0. And my new z is at negative 1, negative 2. And now I've dilated my figure. My last learning target is just being able to name the translation. So in my first one, this footprint has just slid over, so it's a translation. On my next one, I have flipped over this axis, which means I'm looking at a reflection. And then in my last one, I have shrunken, so I'm looking at a dilation. Hopefully all of this is ringing a bell. Feel free to reach out and I will do my best to help you.